When you're solving a system of equations, you're looking for which x's and y values satisfy both of the equations at the same time. So what you're going to do is graph both of these equations and find where they cross, because wherever they cross is going to be the solution. So I'm going to just graph this first one. The b is -1, the m is -3/2. So you go to -1, put your dot, and go down 3, 1, 2, 3, and then to the right 2. When you're graphing a negative slope, you only have one of the two numbers is negative. Because if I go down and the left, then that makes it a positive. So I'm going to get another point on here and go up 3, 1, 2, 3, and then left 2. Okay, so notice up is positive, left is negative. And looks like they'll line up perfectly. So there's my first line. I'm going to graph the second one in red. So I'm starting at -3, that's the b value. If I go down 1 and right 2, look at that, that's where they're going to meet. I could go up and left. But really what I'm interested in is that point where they overlap. Okay, so this point right there is the solution. So I'm going to give the x comma y. So the x is 2 and the y is -4. You go down, you go right 2 and then down 4, and you hit that point. So that's how you solve by graphing. You just graph both equations and then find where they cross. Now, I had a good question about how to graph this without graph paper. If I was doing this on my own, just regular notebook paper, this is how I would do it. I would just graph, make an x and y axes, and then I'm going to graph the first one first and start at -1. I'm just going to put one mark for -1, put the dot, and then I'm going to go down 3, 1, 2, 3, and then to the right 2, and then I'm going to go up 3. There's 1, 2, 3, and to the left 2. And so there's the first line. And then the second line, I'm going to start at -3. So 1, 2, 3. And then I'm going to go down 1 and right 2. Up 1, left 2. There's the second line. So obviously it doesn't look quite as good, but it'll still work. You notice you hit that point twice. So then you can still give me the x comma y for that point there. So just go 1, 2, and then just count your tick marks down. So the x value is 2 because I went over 2, and then 1, 2, 3, 4 tick marks down. So it's the same intersection point. You'll have to be a little bit more careful when counting the x's and y's, but it'll work just fine. Don't add more tick marks than you need to. Notice I didn't start by making a bunch of marks on here because that just makes it harder to read. It's harder to tell if this point is coming from the 2 or the 3, or maybe even the 1 if I didn't do things very well. But yeah, that's how I would do it with, with regular notebook paper. Also notice the little dot there when you're counting over or up in some cases. If you put a little dot, it can kind of help you count which one it should be at. So this little dot's at -1, and then the big dot where my line is at -2. So that might help you. Now the only difference with the rest of these is that you don't have them solved for y to begin with. So we got to get the y by itself first. So I'm going to take this top equation to start. 3x minus 4y equals 8, and I'm going to get y by itself, just like on the assignment from yesterday. So I'm going to subtract that 3x on both sides, and drop the -4y equals, put the -3x, and then plus 8. Remember, don't combine numbers and letters, you just list them out. And then I'm going to divide everything by the -4. And that's going to cancel those. It leaves the y by itself. And I have 3/4x, the double negative becomes positive. And then 8 divided by negative 4 is going to be negative 2. So there I got that one solved for y. I'm going to come over here and solve the other one for y. So I subtract the x. I've got 2y equals negative x plus 6. Remember, don't combine x's and numbers, list them out. And I divide everything by 2. So that cancels those, leaves the y by itself. There's a negative 1 in front of that x, so I'm going to put negative 1/2 x plus 6 divided by 2 is 3. Now I can graph both of my equations and find where they intersect, and that intersection is the solution. So what if they look like this? It's the same idea as the other ones. You want to get the y by itself so that you can graph them. Okay, so I'm going to take this top equation first, and my y is right there, so I want to remove this negative 1 and then negative 1/3. So to get that negative 1 out of there, I'm going to add 1 to both sides. Okay, so it's going to cancel the negative 1s, leaves the negative 1/3 y equals 0 plus 1 is 1. Now, how do I get rid of this negative 1/3? Well, remember, if I have a fraction, I can multiply by the denominator and it'll cancel it out. So I'm going to multiply both sides by negative 3. So multiply that 1 by negative 3 on the right-hand side as well. So the negative 3 times the negative 1/3 cancels out the 3's. Double negative makes it positive, so here I just have 1y. 1 times negative 3 is negative 3. So there I have that one solved. Now I'm going to take the other one and solve it. So I have 0 equals 3x minus 3 plus y. So wherever that y is, okay, I want to remove the other things. So I'm going to add 3 to both sides. Or maybe I could just subtract that y. So I have two options. I can move both the 3x and the negative 3 over there, or I can just move the y over there. It doesn't really matter which way you go. I mean, moving the y over, you're only moving one thing. So you might want to do that, or you can add the 3 and then subtract the 3x. It'll work out the same either way. So since I already started adding the 3, let's just continue that way. So those 3's will cancel. 0 plus 3 leaves me with 3 on the left side equals 3x plus y. Now I'm going to subtract that 3x over 3x. Again, I can't combine the 3 with the 3x because they're different, right? One's an x, one's not. So I'm going to just list them out. Negative 3x plus 3 equals y. So there you go. Y is by itself, and I'm done. I can rewrite this if you need to see it the other way, and just put the equals on the other side, right? So there, I got it solved. Now I can graph it. Okay, so if you want to see graphing one more time, here we go. So I'm going to graph the screen one first. Start at positive 3, negative 3 slope, so 1, 2, 3 over 1. And I can continue that pattern. I can't continue it the other way, but getting 3 dots on is going to make things a little more helpful. So now the graphing the blue one. Remember, when it's y equals, this is going to be a horizontal line. So I go to where y equals negative 3, graph my horizontal line, and there we go. So they're going to intersect at that point right there. So I've got x equals 2, y equals negative 4. So that is my actual solution. Okay, so don't forget to give me the x and the y for each of these, because that's the actual solution. The graph is your work getting you to the solution. All right, ask me questions if you've got them.